Alrighty. uh, Depth first search recursive. I want to see your test. So background,
Okay.
we were playing with this recursive tree thing that beat us up on the first run. For some
Uh,
reason, we were not returning the right thing.
yes. You might want to show the picture of the tree, maybe
Yeah, let me pull it
for
up.
other people mostly.
Let me grab that. Let's see, where is it? I'm fine. I'm looking for it. Okay, give me 1 second. How long after did you figure it out?
Think like 20 minutes.
Yeah, I had to go into some meeting, but then after a while, I came back to it and I needed some additional help. Let me see here. I think that's it. Okay. Now, all right. Let me try to do a screen share here of this part because I have so many things on my screen right now. So this is the one. So we needed to
Yes.
write a recursive method function that would first search the current payload for a number. If it didn't match, then it would go to the children and to the children's children and to the children's children until it would exhaust, come back, and keep going.
Payload,
And
payload, sorry to interrupt. Just want to make a clarification. With payload, some people might not know what you mean. You mean the number itself on the node, right?
exactly. So the number we're calling the initial payload, but yes, the number and the children. So those are the two goals. So find the number. If it doesn't match, then go look in the children. And the children is just the same structure here. Let me open up. Let me see what I have here. Oh, that's not it. I'm looking for where I was doing this.
Hmm. I keep seeing the picture. If you're trying to show something else,
Yeah, let me. I was trying to look for the initial code that I was
oh,
sharing with you,
okay,
but but that's fine. Here, let me stop the screen share for a minute.
okay.
So yeah, I was we were trying to do this right. I can use this right here. Let me just open a new. And yeah, this will work. We can do it like this. Let me share the admin again. Can you see that?
Yes.
Okay, so that was the initial structure. Let me put Ruby here just so we can get some stuff. So that was the initial structure. So that is corresponding to the tree that we were sharing. So that tree initialized payload would be the number, so
Mm-hmm.
number two, and then the children is just pretty much another tree. And the way we were doing that is this way. And this is borrowed from an exercise from course I took, but so this is how we were initializing them. So these are the leaves, the branches, and then the trunk. So 2,
Yeah.
5, 7, 6, 9, 4, 7, 9, 9. So that's the structure. And
Yeah.
let me just show the tree again so that it makes sense.
I name my class Node because I think it makes more sense. At least the way I think, they're more like nodes than complete trees itself. They're like parts of the trees.
Yes, yes, I agree. I agree. So naming aside nodes, trees, that's pretty much what we were trying to accomplish.
Mm-hmm.
So we were stumped for a bit because every time we ran our old code, we kept on running into this returning the wrong thing, right?
Yes.
So so we were trying to, let me see if I have it here. I think I have some samples of what we were doing before. Where is this? Oh, I have it here. Let me pull it out again. Sorry, I we launched this like on the last minute, so I don't we don't have everything ready.
Hmm.
Let me see. Okay, so we started. Let me share the Atom here, and after I share this setup, then I'll switch it over to you so you can share.
Okay.
So one of the first attempts was something like this,
Yes.
right? So what we were finding when we were running this code is that we were not returning the node we wanted or the tree we wanted. We kept returning like the initial children of find
Yes.
of the trunk, and we were even getting kind of desperate. So we were seeing why isn't it returning. We even tried doing something like tree equals, and then here we tried something like tree return x if x equals, so thinking that it would match self, and then we would match it to
Yeah.
itself and return that, and that didn't work. And then we started doing puts and gets, and then we even for a second considered raising errors.
Yes.
And I brought up this whole, well, what about catch and throw?
Oh no! Please, the world should not know that those things exist. And
Okay, disclaimer, this was not he's too sticky to that. That was just me getting desperate. All right, so now you were smart enough to write some tests.
yes.
I stopped recording. Dang it. Oh no, I stopped screen sharing. Never mind. All right,
Hmm.
so you were smart enough to write some tests on this. Much smarter
Yes.
than I am. So go ahead. Let's see your test, and we'll go through.
Okay.
Finally, I was able to figure something out with some help, but let's compare notes here.
Okay. Just a question first. Is this something you're doing just for fun and practice, or do you want to implement this in some project? Just
Fun,
curious.
fun practice and self torture.
Okay. And do you plan to do more like this?
I like it.
Similar?
I like figuring things out. But yeah, it's one of those things that I went back to. I hadn't done this in a while,
Hmm.
and it was a challenge from when I was learning. So I said, let me go back. You know, a couple, 2, 3 years later, I should be able to figure this out without a problem. And then 2 a.m. and no go.
Yeah, it is mostly knowing the algorithm more than knowing Ruby, I think.
Yeah, and you know what? For me, well, once we discuss it, I think it made me aware of something non-related to depth first search, more related to recursiveness than this. So,
Yes.
but yeah, we'll talk about that.
Okay, so I'm going to share my screen. Can you see my screen?
Yep.
Okay, so I wrote some tests using Minitest, and here is my setup. And I have the nodes. I create some nodes, and I gave them names corresponding to their number. So N9 is 9, N1 is value 1. And my root, I also created a root variable, and my root in this case is 3, which has 3 nodes, and 2 and 5 and 9, and 2 itself has another node, children. So this the children, this the value, and N5 has also one children. So that's my setup. Okay, any questions about that?
No, that makes sense. It was just changing nodes for trees for nodes and getting some good variables that we can reuse. So it makes sense.
Yes, yes. So now we have a few tests. I try to test all the all the numbers to make sure it's working. And I also wrote this extra method to make extra sure this thing what you're supposed to do. So the first method is trying to test the order. So instead of finding a number, I'm telling it to do the full search, and just give me the values, the numbers in the order they were found. Okay.
Got it.
So that's the get order method, and the only thing it needs is the root node, which is n3, and this is the expected value. So expect this to go in this order. So this is not the same tree that you showed before, so people don't get confused. It's not the same tree. I just came up with my own numbers. Okay.
Right, right.
So three, if you show that three will be at the top, then we will have two there, and under two there will be a one. So just so you get an idea, it will look something like this. This will be an 8, and that's that. That's the tree.
Yep.
So the order is first 3, then 2, then 1, because what we are doing is called depth first search. Depth. So depth meaning you can go in deeper, deeper, and deeper, and deeper. All the deep you can, as much as you can. And in this case, and you start from the left. So the root 3, then 2, then 1, then you can't go any further. So you need to go back to the root. Okay, so if you had another number, like let's say we have 0, then it will do 3, 2, 1, 0. In this case, there is no 0, so it goes back after the 1, go back here, and the next number is 5, 8, go back, 9. So 3,
Mhm.
2, 1, 5, 8, 9. So this get order method does exactly that. It goes over this tree, and it returns an array with the numbers in the correct order. And let me show you. Let me show you this method. Don't look at this one yet. You're not supposed to look.
It's
That's
okay. I was looking away right when you said that.
you can look at the notes. So I use a stroke, and that's just for because I'm lazy and I don't want to type initialize and all of the things. Okay.
Yes.
This is the easy way to get my note. I have the value and the children. And then the get order is very simple. I have two parameters, the node, the root node, or the starting node, which then we become the children as the method calls progress. Then result, which starts as empty, and then we get result. We push the current value into result. So what this means is when we start here, it pushes 3. So it will look like that. Okay,
Mhm.
that's right away. Just as you call the method for the first time, 3, push 3. Then we go over the children, and the children with each, and we call the get order again. So this calls something, if you're not familiar with this called recursion. And recursion is calling the same method over many times, so it gets the work done. Okay. And this time I'm calling with the children node. N is one of the children nodes. Okay, because we're using children.each. And N is one of the children nodes, and we're passing around result. So this go and keeping track of the total. This always the same array. So what happens when we find the first get order is that the first children is 3. No, first children is 2. So the 2 gets push into the results. Okay, and then we go over the children of 2. The children of 2, and the same happens. Get order again. So let me show you what this looks like. 3, the node 3, node, so you can see it's not something like that. And then we have
And then just you're passing the array with the results as they go.
yes. So we kept passing the results around, so they keep accumulating, adding up. So that's what's happening. But notice that these are nested calls. It doesn't return right away because we're calling the same method again. Okay. So where there is no more children, we return the result and then go back. There is no more children. We go back and we go to the next children. So the next children will be, let's say, there will be 5. And we repeat, we put the 5 and we just keep going like that. Does 5 have any children? Yes, it has 8. So we call get ordered again. 8. Does 8 has an have any children? It doesn't. So we go back. We go back to 3 again. Does 3 have more children? Yes, has 9. We go there. We put where I forgot 8, 9, and we're done. And 9 doesn't have more children, 3 doesn't have more children, so it returns the result.
Yep.
And that's how that works. Okay, so I hope that made sense.
Makes sense.
Any questions?
Nope. Nope. I'm good right there.
Okay. So do you like my get order method?
I like that. Because yesterday we were even skipping from like 6 to, well, from one node and we were just skipping one and going to the next leaf. And so I think that's what prompted you to write this.
Yes. So now let's see the big one, the finding. So for finding, I wrote 1, 2, 3, 4, 5, 6. Well, like 8 tests. Thing, and I'm going to run them for you so you see them passing, all of them. You can see they are passing. Okay. So what I did is I'm looking for the note itself, right? Because that's what you wanted. You wanted the note itself. Is that
Yep,
correct? So
exactly. I
what
want the
I'm
actual node.
yes. So the actual note for 8 is N8, and I can get it from my set of instance variables. So I can compare directly against the same object. So it's not even a copy of the object. It's exactly the same object. And then I have my find value method, which has the root, the same root than before, and the number we're looking for, 8. Okay, so let me show you what I came up with for find value.
Uh-oh,
It,
hold
it,
on,
it,
hold on,
it's,
hold on.
it's not perfect, but
All right,
it works. It works. Are you ready?
all righty. Let's see.
Uh, so this is it. What I did, find value takes the node and the num, which is the value we are looking for. Okay,
Uh-huh.
number we just to make it clear. And then what I do, the first thing is return the node if the node value is equal to num. So what that means, we found it. If we found it, then we return it. Okay,
Yep.
and then I go over all of the children, and here I think is the key part. I'm using map because map is going to keep keep going, so it's going to do all of the numbers. That which not perfect. It's not going to end when it finds the number. Okay,
Okay.
but map, what we do is collect. So another name for map is collect. In fact, it is a valid method name. It's the same. There are map and collect are the same. Map equals collect. Okay, and the collect name can tell you something about what map does. It collects the results. So I'm collecting the results for all of the nodes, and if one of the node is the node that we want, it will be here. It will be in this list return.
Yep.
And I need to do the compact and first because if I don't, they will be nil values because every time it doesn't find it, you can see it's a big mess because
Yep.
there are
Nailed all
nils
over the place.
and it returns nil when it doesn't find anything. And first, so it gets once the nils are removed, we get the first value, which is the node if it's there. Okay, so that's what I'm doing. The key I found, so I was thinking how recursion works, and I think so. There is something that needs to like keep going up the call stack. So you need
Yep.
like a bubble that keeps going, or like a glove, something like that. I'm not sure how to give you a visual image of that, but you want to keep going up, 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 up,
Yep. Yep. Yep.
and keep returning the value that you found. That's we map works here because when it finds one of the nodes and it matches, it keeps returning it until the last call, until
Uh-huh.
the last children. Then it finally takes everything, compacts it, and returns whatever it is. And if it's nil, I have a test for that. So I thought about that. I'm testing 15 and -1 as nil. So I'm testing that when there is no phone, the value is not found. It's 8 or 3. It returns nil like it showed instead of something where it something strange like an exception or something.
Yep.
So that's my code. So what do you think?
I like it. I like it. I think this is fun because yeah, you're gonna be mad when you see this.
Okay. So let me show what you have.
Okay, let me share what I have, okay? And I cheated because I got some help, so I'm not taking credit. But but it was beating me up, so I'm like, nope, I need to figure this out. I need help with this. So do you see my
Okay.
screen?
Yes.
Okay, hold on. Let me do this. Okay, cool. So we have the same thing, right? We have the tree. You just called this a node, but it's
Mhm.
essentially the same thing.
Yes.
So the only difference is you built your method outside of the class. I just put it in as an
Yes.
instance method. But it's not the same thing. The only difference here, if I built it like you did, would be I would add in here I would add in tree or node, pretty much the structure.
Hmm.
But it's the same thing. It's gonna do the same
Yes.
thing. So you ready?
Yes. Let's see it.
And I'll tell you this, and you're gonna like this part. So two things.
Okay.
Two things. You mentioned one of the key parts. You said your collect is returning a lot. If you don't
Hmm.
do a compact, you have to do a compact because you have what in there.
Okay.
And you said that yours doesn't stop; it keeps going.
Hmm.
So here, you're gonna like this. Ready?
Okay.
One, two,
No,
And
uh, okay, let's see what you have.
okay, so I'm returning self because I'm using it in the instance if the number equals the payload,
Okay,
right?
that's the same, pretty much
Same
the
thing.
same I had, but I'm returning the node, but you return itself because you are inside the class. So some
Exactly.
people might not understand the difference there.
Yeah, so if we were passing in the node like that, then right here, instead of returning self,
Mm-hmm.
we would return the node.
Yes.
So, but since I'm inside the class itself, then I can return self. Because the
Yep.
way I'm doing this is I would take the trunk or the first leaf, what in your case was the root,
Yes.
and then I would do root find node 6 or 5,
Mm-hmm.
whatever. So that's the
Okay.
only difference. Okay.
Yes.
Okay. So now here's the cool part. This one stops when you find it. And the trick is this, and I needed to get help with this. There's two things that this method can return. It can either return the node or it could return nil if it didn't find anything, right?
Mm-hmm.
So at the end of this, if we still got through everything and we don't find it, then what we return is nil. So now that
Mm-hmm.
gives us one return. The other
Okay.
possibility is to return the actual node.
Yes.
So now we have this here, return node unless node equals nil.
Huh.
And this is the whole key part. And this
Yes.
is the part that I was missing. So why don't you, because you have the test, can you modify yours to follow this pattern here and see if your test still passed? And if we can stop once we find it, we won't have to keep going.
Okay. So let's see.
I'll keep my screen share up here. That way you can reference back to it if you need to.
Mm-hmm.
And screen share yours also.
Okay. Let's see. Children. Is it the word? This word. Now that children.
Okay, let's see. I don't see your screen yet, but in case.
Okay, I'm sharing now. Now that children.
Yeah, there you go.
Child. Uh, Note. Cycle this. Find value. Send it to pass. So it will be something like that, right?
I think so. Yeah. The only thing is, let's see, because yours is already called node. I don't know if it'll make a difference if you need to use a different variable right there. But it might just overwrite it. But just for sanity check, I would use
Oh, okay. Nil, 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 nil. Everything return nil.
find
Well,
value.
some are passing. So that's interesting.
Let's see. Can you do temp node equals and then return temp node?
There, them now.
Temp node, temp node, temp node. Everything inside that.
Oops. Okay. Nope. Same
No,
thing.
no, no.
The
Okay,
same.
so something's different when you do it this way. So node dot value equals num, find value, node dot children,
Oh,
do
oh, the
children.
thing is this.
Oh, children.
So it needs to like find value like that, I think. Let's see. This is the actual children. For each.
Node dot children dot each.
Oh,
Yes,
it's working. There.
sweet. There you go.
Nice.
working. And you don't have to, you're not going to get any, you're going to stop once you find it. So if you put a puts in there, just so you can track what's happening, you'll see that it doesn't keep going after there. No, put it in the right before the return, the
Okay.
first return,
Okay.
right at the beginning of the method. And then I would just put node and then node value.
Node. Oh, like this. You
Yeah, to
mean?
compare. Yeah, to compare.
So the fish, since I'm running the test, the first one is looking for 8. Uh, 3 to, let's see, 3
And
to
what
3 to 1.
the first one is just doing all your orders, right?
Yes.
That's just your first test order.
I will need to skip like half of the stuff. Let's see. Skip all of the things. So that's looking for 8. Now let's
And it,
look for 2. Yep, it stops.
yep.
So let's see. I was thinking about some refactoring of this. I think maybe we can improve it. Thinking, let's see. Them out. The will that do it? No. How about? Oops. Okay. I don't think we need them out. We don't.
Yeah, I don't think so. Now that I see it, I think we should be good. Try it again.
Working.
Yeah.
What happens if you don't have this nail? Okay.
Yeah, that breaks it because then you're returning.
Let's see. Thinking about something like define it. Define it outside. Should be able to do something like this. See? No, note or so note can be the note or nail.
Okay.
No.
Nope. No, because you're not returning anything.
No, because I'm setting this let me do this. How about that? Nil nil nil.
No, nope, nope, nope. Because there's no return.
Return is
So
here.
on your node.children,
But if the because but the decision that is found is there. Oh, but it will not be. It will be value. Oh, yeah, I get it. Yes, I get what's going on. But what if
and
we
then we,
do that? No. Hmm.
yeah, I mean, we don't need the temp node. That part you can skip, right? You can
Yep.
just do node.
Yes. Yes.
Yep. I like the node.nil, but I think nil or
Mm-hmm.
whatever, that's kind of like that's at least the lesson I took out of it, which is with recursion, it's really easy to lose track of what you're actually returning.
Yes. Yes. Yes.
So you want to control your returns at every point. And for me, like the key part of this was that nil at the end.
Mm-hmm.
Like if nothing works, then I need to know what I'm returning. And the easiest
Yes.
thing I can
Yes.
return is a nil, right?
That's a good point. That. you need to control your return on recursion. Yeah.
Exactly. And I think because I wasn't doing that all throughout, we were just hitting roadblocks with it.
Yes, because if you don't do that, then what you're returning is the children itself
Exactly.
because of it.
Yep. So yep, that was the adventure with it.
Yeah, that was fun.
Oh man. But hold on, I found the thing. Let me see if I can share this. Let me see. Yeah. Oh, did I delete all this? Hold on. It's just that let me look for it was it's funny like to what extent I went with trying to do this. Uh Let me copy it in here. Let me share the application window again.
Hmm.
Remember this?
Yes.
So like trying to figure out what we were doing in self and tep and like we were pretty close, but
Yes.
again we kept forgetting here what happened. So so yeah, that was fun. Oh man. And it's funny because like these little challenges, they kind of push you and here you are building some other things. And this is not something you're gonna face in everyday coding, right? It's not like but even though I might not do a tree search or depth first search, I might need to do some recursive calls. And then now for sure I'm
Yes.
gonna make sure like, oh wait, what am I returning at the end of this? So I
Hmm.
think that's
Yep.
all right. All right. I think this was a fun prep for reviving Ruby Monday again.
I'm glad it's that happening.
We have to start. I'm probably going to start doing it. I might need to be a Ruby midday or a Ruby morning just because of schedule, but we should do something.
Okay.
All right. Well, thanks. I'm going to stop the recording, go chat for a little bit, but thanks.
Okay.
See ya.